Now, let's look at an example where we decide whether some relations are in fact that special thing called a function. And how that might be requested of you is to say determine whether each of the following relations, that's an A, is a function. And I'll put Fn for function. Let's start with the relation F, which is the set of ordered pairs 1, 2, -2, 5, and 3, -1. Well, one way that I could solve this, I might be able to solve this just by looking at it, but I want to give you a method for longer problems, is to write all my x's in order. Or rather, x coordinates. I've got a -2, and I've got a 1, and I've got a 3. So those are my x's. And I should perhaps have left a little more space, but I'll write the second step down here. My second step is going to be write the y's, the y coordinates. So let me add them in a little table here. The -2 is paired up with a 5, the 1 is paired up with a 2, and the 3 is paired up with a -1, and I've used up all of the ordered pairs in my set here. Well, if it's a function, each of these x's is going to be paired up with exactly one y, and they are. They match with 1. Life is good. This is a function. Okay? Now, let's look at another relation. This relation is going to be given the name H, and it's the set of ordered pairs, -4, 1, -2, 1, and -2, 0. Let's make a list of x's and y's again. If we make a list of x coordinates, we have a -4 and we have a -2. If we make a list of y coordinates, we have a 1 that's paired up with our -4, and then our -2, we have a 1 paired up with -2, and then we have a 0 paired up with -2. Now we have a problem. We have right here one x, and we have two y's matched up with the same x. This is not a function. It is a relation, but it's not that special kind of relation called a function.